Today, I thought I would talk a bit more about our work in terms of using low Earth orbit satellite constellations for security and privacy. And a lot of this work is recent work that I've been doing with my collaborators, Lee, who is a PhD visiting student here at University of Edinburgh, and my colleagues at the University of Waterloo, Prabjot, Diogo, and Noura. So it's all intermixed. I want to give you a high-level view of what kinds of problems we're trying to look at, what is interesting for us in terms of using low Earth orbit satellite constellations, and hopefully, pique your interest in the kinds of things that are going on in this space. So just as to, I'm sure I don't need to, go too far into explaining this, but basically, low Earth orbit satellite internet has progressed a lot since the recently it's become quite a big thing, and a lot of constellations are going up. And here, what I want to point out is that, it's becoming quite practical to use satellite internet for just everyday browsing and things of that nature. There was a time where there was a lot of latency, and that was sort of considered something that was a killer for, highly interactive applications. But that latency has gotten quite reduced because of the low Earth orbit. The orbits are much closer to Earth, and then so the latency is much shorter, and the throughput is much, much higher than it used to be. And this is all, of course, through the efforts of different companies who are pushing at the forefront of making this technology as useful as possible. So companies like SpaceX and Eutelsat's OneWeb and Project Kuiper, which is Amazon. And on this picture, I just want to point out that, we can see that there's different kinds of links. So we have your usual fiber link or terrestrial link. We have a radio frequency link between satellites and ground stations. And we have like intersatellite communications using lasers or light. And these different links have different characteristics and speeds. And so we wonder, like, is there a possibility of utilizing these things? So before I get into that, though, I just want to give you a quick high-level overview of privacy and the metadata privacy and protection that I'm talking about, just in case there's anyone who's maybe not clear on these things. So metadata is contextual information about any communication, right? And while we have cryptography cannot protect us from metadata leaks. So cryptography can help us protect what we're trying to say to the other party, so the contents of the messages, but it cannot hide things like the time of the message, the duration of the message, the length, or who we are communicating with potentially, right? And so in order to protect these things, we need to have some sort of tool to use. I'm sure some of you may have heard of these tools, but I'll just present them as if we're coming at it fresh. So here you want to connect to all these nice websites, and you're able to connect to them. But then, of course, all your connections are observable on Earth because, you have your ISP, you have government authorities, you have various other entities like, your IT department, the websites themselves. So you're under observation, and maybe you don't like this, right? It's not great for privacy, at least. Even if you have encryption, like I mentioned before, metadata is leaking, and it's giving information about at least who you're connecting to and what you might be possibly talking about. And then, of course, after someone is able to observe what you're doing, there can be more controls in place to say, maybe filter out, certain kinds of traffic. And maybe, you decide, hey, maybe I want to get around these blocks. So you start using tools like Tor or mixnets and things of that nature, or VPNs. And then everything is great again. But then, these tools get, popular, everyone finds out about them, and then people figure out how to start blocking them. And so you're upset again, or not so happy. And then you find out that there's ways around those blocks themselves. And then maybe that enables the connection to these sites again. And so what we see is that there's this arms race, and it's very ad hoc, and it's reactive. And so this is the environment that we are working in the privacy enhancing technology space, which is the background and my area of interest and the topic of this talk. So that gives you context, right? So I will focus on a particular tool called Tor. I don't know how many of you are familiar with it, or maybe you've heard of it, but I'll just give you a quick overview of what kinds of things we're interested in. So Tor provides this property called unlinkability. The idea is that the two parties talking together, communicating together, A third party should not be able to tell which two parties are talking to each other, right? And we might even want further the recipient not to know who the sender is, right? Who the originator of the communications are, right? So this gives us a property called unlinkability. And that's the property I will focus in on today. Now, the Tor network is, thousands of nodes, like around 8,000 currently. And all these nodes are operated by untrusted volunteers. Untrusted in the sense that we don't necessarily trust them. Not that they're definitely corrupt or adversarial, it's just that we just don't have to trust them. And we assume that the majority of them are non-colluding, okay? Meaning they're not sharing information about with each other about the connections that they're observing, right? So this means that Tor can resist something called the local adversary, or an adversary who can just view some parts of the network, but doesn't have the complete picture of the entire network, right? And the kinds of attacks we're interested in are these end-to-end compromise attacks, where we can correlate activity happening on one side and activity happening on the other side, and be able to tell which two particular entities are speaking to each other, basically breaking this unlinkability property that I pointed out in the beginning, right? And basically, the ability of the adversary is totally dependent on their budget and ability to place themselves in the right place. Okay. So the Tor network this is a graphical view of what that looks like. What the user does is, out of the thousands of nodes, they pick 3 nodes and then make a circuit, build a circuit through them. And then once that circuit is built, they send, and this circuit is, protected by cryptography. I won't go into the details of that. But needless to say, once it's built, a person can communicate between themselves and the other end, and we get the properties that I was talking about, so that unlinkability is present, right? Okay, so that's the setup. So we have the system called Tor, and then we wondered, would it be cool, or what benefit would there be if we could somehow use satellite connectivity to make Tor better? And the reason we think this is because of this figure here. Now, if we look at the diagram, let's ignore the satellite picture of satellites for a second. Look at the diagram and you see this green circuit. So you're a client trying to talk to this server that happens to be in Florida and you're somewhere in Canada, and you make this green circuit. So this path looks pretty small, right? So you hope that the latency would be pretty low. Of course, it's entirely possible when you are picking these nodes on the Tor network, that you picked nodes that were very far away from each other. So you make a circuit that is this purple path that goes on from Canada to somewhere in Europe, all the way down to Australia, then to Brazil, and then to the server. So that's a much longer path and much higher latency because, the paths are longer. And in Tor, ideally, you should not pick your paths in any way that can help the adversary figure out which destination you might be going to. Like, for example, you might optimize to pick shorter paths only, but then the adversary would learn that, if this path is coming out here, it's likely to have come from somewhere close by. And so we don't want to give the adversary this kind of information. So what we'd like is to maintain our ability to pick paths completely randomly, where we could pick nodes that are very far away from each other and still get some sort of speed up. And we think satellites could provide that, right? So what we would like to do is, on those long paths, use a satellite connection instead, right? After a certain point of distance between the 2 points that are communicating to each other, the satellite link, as we believe, should be faster to go, like point to point, well, not point to point, like up to space and then down, versus through the internet that has to take a very long and potentially not as short route, right? So that's basically the very first idea that we had, is, can we improve performance of Tor by utilizing satellite links? So this is work under submission, but I'll talk a bit about what we're talking about here. Okay, so basically this is the setup. You're some user, you have some dish, like a space, a Starlink dish, and you are bouncing your communications off some satellite that's above you, and it goes down to a ground station, and then it goes through the ground to the web server you're trying to communicate with, right? In this picture, I'm showing other kinds of links in dotted lines, but these are possibilities that we could use. So there are potentially, three different routing strategies. So the top left is the possible types. And then in B, in the top right, we see the traditional routing, which is every relay communicates with every other relay, just using, terrestrial links, as we do today. And then there's the Starlink user, where the relay bounces the connection off a satellite, goes down to the ground station, and then the rest of the path is over the ground, right? And then we have D, which is what we're imagining the future would be like, which it's not too far-fetched because things like this, inter-satellite connectivity is being enabled, right? Where the nodes never touch down until they get close to the destination, and then they come down, right? So you spend most of your transit time in space over the laser link rather than over any terrestrial link, right? So you're trying to reduce the amount of time you spend on going over fiber links, right? Cool. So these are the different kinds of strategies that we consider. So what we'd like is, as you're building these circuits or as you're traversing the Tor network, we'd like to have at each point, at each relay, as you go through the network, have the ability to decide, shall I go over the terrestrial link or shall I go over a satellite link? Here we're assuming all the relays have satellite links enabled. And so they're like dual homed and they're going to, choose, right? Ideally, that's what we would like, right? And the way you could do this is either you allow the relay itself to decide for you based on the fact that it would know which connection is probably faster. So you could make it could divert the connection over satellite, it could divert packets over terrestrial, depending on what, what was most appropriate, what's fastest. The other thing is the client could dictate, I want my circuit to be built over this portion, this segment to be over the satellite link, this segment to be over the terrestrial link, based on some information they have about the network that comes through the consensus document, which is part of Tor anyway. You get it every hour, right? So you get an update every hour of what the Tor network and this terrestrial and satellite links look like, right? So that's how you might, incorporate satellite links into the, way things work. So we wanted to test out this idea. So we built a simulation tool where we collected a whole, like, millions of Tor circuits. We basically ran a Tor client, didn't allow it to make actual connections to the internet, but just had it build millions of circuits. And so we had a pool of circuits that would make, like, this is the normal algorithm. We're not changing it in any way. Then we went to the internet and basically crowdsourced information about ground station locations, about the two-line element information about all the different ground stations, information about satellites. So we did a scrape of that information. And then we built this graph routing simulator that would basically try to find the shortest path given the weights on the edges, which are basically the latencies of what we believe terrestrial links would have and satellite links would have. And that would give us, information about reachability, what routes to pick, the latencies we could expect, and also visualizations if you would like to see pretty pictures, right? So this is a tool we built, and in order to evaluate our idea, okay? So of course, we had to marry this with some real world information, like, for example, what is the actual speed of satellite links, right? So we leveraged some of the work that was done previously here at the University of Edinburgh and other places about trying to measure this, right? So we took measurements of satellite links themselves. Then we also had to deploy some Tor relays and do measurements of actual Tor connections over satellite links as well as terrestrial links to kind of give us the ability to put the weights on these red lines over here, right? So we would know what the latencies actually were, right? Or expected latencies would be. So we got all of this information together. We did a lot of measurements and we got tons of graphs, right? And tables. Don't worry, I won't go into any details here about them, except basically give you the takeaways, okay? So what we saw was that in the small scale evaluation that we were able to do, that we could get a 70% millisecond latency reduction on average for around 40% of the circuits, right? So basically, we were seeing, based on the variability and from the statistical information, that most of the impact was to reduce latency variability over terrestrial links. So we were really helping links that had a lot of variance on them. And satellite somehow was a bit more stable, right, for those links. We also saw, and this was for a single bend pipe, right? This is what we can do today with the service that Starlink is selling customers, which is the single bend pipe, right? Where you go up into space and come down to the nearest ground station. So you're basically spending a lot of time on Earth rather than actually in space, right? But then if we allow ourselves the flexibility of using intersatellite links, right, which are not currently like enabled, they are enabled for certain places on Earth, but not everywhere. We saw a 20% latency reduction for, on average, for 80% of the circuits. So a large number of circuits, right? Where we allowed the selection of the link, either over satellite or over the terrestrial link, based on the current conditions, right? So we have a way of doing measurements every hour, and we get the most up-to-date information to use, right? So in a nutshell, what we find is single bend pipe does not really produce significant latency reductions, and in some cases actually causes a larger amount of latency. So the current Starlink with single bend pipe, there is potential, but single bend pipe by itself is not going to really be useful for a large majority of cases, given the kinds of circuits that we make on Tor, right? However, if we had intersatellite links, they do significantly reduce the latency when the node is dual homed, and it allows us to choose between terrestrial and satellite links, right? Even if you are single homing it, meaning you just decide upfront if this node is going to use a satellite link or a terrestrial link, right? And just use that in a fixed way, we still see that you can get improvements, but not as high as the 80% circuits that we saw earlier, right? Now, of course, this was taking a lot of, we emphasized like trying to see what performance gains we could get, but we should consider the security implications of doing this, right? Of course, one of the main ones is if you're going to use one satellite provider, you want to avoid both the entry point and the exit point of our circuit to be observable by that entity. So we don't want Starlink to observe both us coming into the Tor network and leaving the Tor network. That gives them that very good local observability that would allow them to break anonymity, right? So what you would do there is you would decide that if I'm going to make a circuit like this where two segments, the entry and exit segments is going to be over Starlink, we would not allow that. We would say, choose one of them, right? And see if it's better to use the exit only or the entry only, right? So that's one way of how you could prevent that. As I said, right, in the beginning, there's these different companies. So it might be that if you purchased service from various different satellite providers, or different relay operators on the Tor network chose different companies to go with, you would not have that issue with a single entity being able to observe everything, right? So that would be one way. We would like to avoid traffic analysis due to satellite characteristics. Now, I'm going to talk a little bit about that in the next coming slides. But what you could try to do to prevent this kind of traffic analysis over satellite links is perhaps to add delays or other traffic perturbations that could, defeat some kinds of traffic analysis. Or you could multiplex your connection over multiple paths, right? There's work done in this regard where, of course, the different paths are all over terrestrial links, but here you could maybe use a terrestrial link and the satellite link simultaneously and split the traffic over them to make traffic analysis more difficult. Of course, relays could misbehave and either lie about the fact that they have a satellite connection or not honor the path that they're supposed to pick for your traffic. So you could do this, you could monitor timing information about your packets and see if they're like conforming to the expected latencies that you're supposed to get if they had taken the right path, right? All right, so that was one particular project where we looked at the performance gains. So then we asked the question, are traffic analysis attacks, specifically website fingerprinting, which I'll very quickly cover, Are they easier or harder to conduct when you use satellite links? Because now if you start using satellite links, does it somehow make Tor more susceptible to certain kinds of attacks? Okay, and this is work that appeared at SpaceSec at a workshop that was co-located in DSS earlier in 2024. Okay, so again, the same setup. It's the bent pipe. We're only considering bent pipe here. And the adversary is this red person who's basically, you can imagine them being like your ISP, right? They can observe your connection from the client to the ground station, but they can't tell what else is going on. Basically, they can't tell where the traffic is going into Tor. So they're capturing the traffic before they even enters the Tor network, right? So just to give you an idea of what website fingerprinting is, basically, you want to see if there's any kind of identifiable patterns or fingerprints that appear even under encryption, right? That appear before the connection enters the Tor network, like that part of it, right? And train some machine learning model to distinguish different websites. So here, like you're going to Twitter or X and Facebook, and what you could do as an adversary, just visit them millions of times, collect a nice data set, and make a classifier that can tell you if you're visiting, which one of these sites, and or maybe more, right? And this is work that's been in the literature for like at least now a decade, right? And it's kind of has very good fingerprinting success rates, right? So we set up an experimental testbed. We collected data using website fingerprinting data over a fiber link and a satellite link, right? And both going over Tor and not going over Tor. So we end up with 4 data sets, right? So we collected about 125 traces for the top 120 websites on the Tranco list. Tranco list is a list of top popular websites. Ooh, it went backwards. And we collected a whole bunch of data here, right? But we had to get rid of a few because some websites were failing a lot on certain of our connections, like for example, over satellite or over terrestrial. So we had to drop some of them. And basically, there's different kinds of, and then we applied machine learning attacks on them. There's 2 types, the manual type where you basically handcraft and engineer the features. For example, we use this attack called K-fingerprinting. And then we applied some deep learning based attacks where it has automatic feature extraction. So these are called deep fingerprinting or DF, and the TikTok attack. So these are very, what you would say, the state of the art attacks. But we wanted to see what would happen when you compare both manual and automated ones, right? And we had a closed world setting where we were trying to distinguish between 75 different websites that we went to. And so when we look at it and we apply these attacks, we see that, the attack success rates are still high and a little bit higher on the fiber than the Starlink, but not significantly, especially for the deep learning ones, right? And it's not that much of a difference, really, right? So what we can say is that actually when you don't do any kind of defense on Tor traffic, going over satellite link or going over a fiber link, you're kind of getting a similar kind of security posture. Or in other words, you're as fingerprintable over satellite link as you are over fiber. So it's no reason to not use a satellite link or a reason to use it, right? And then if you do defend them, there's some defenses. I won't go into what the defenses are, but just think of it as like padding traffic, changing the timing, doing some traffic shaping so that, packets get moved in time, right? We're seeing that defenses are still continuing to have an impact on the attack, regardless of it being a traffic over fiber or over Starlink, over satellite links, right? And certain attacks, which are currently quite, let's call it some of the state of the art, like front 1 and front 2, we're seeing a lot more difference in their, what you might say, success of the attack. So over Starlink, the success seemed to be lower, and over fiber, it's a much higher, right? Even though you would say that, 60% isn't that great of an attack, right? So in a nutshell, we see that using satellite connectivity, the impact it can have on doing fingerprinting attacks is that it doesn't seem to make a huge difference, but in terms of defenses, we still need to do some work in order to close the gap between satellite links and terrestrial links. So there's work in that direction. So the key takeaway here was that website fingerprinting can reveal browsing habits over encrypted traffic, which is what I was saying, that we don't see much difference between the two. It's still a not yet explored, very well explored area of work. And website fingerprinting is still as concerning over satellite links as traditional fiber. And with that, I'll end it and I'll take some questions.
Thanks, Professor Elahi. So I think Nishant has a question or comment. So Nishant, would you like to speak to it?
Yeah, I mean, basically, I was trying to say that, I think, Tariq, you were at some point saying that you needed multi-provider links going across from Starlink to OneWeb or whatever. That's still quite, uh, it's still not in practice available, right? Probably intersatellite links will become available much more quickly, more widely than links between providers within space.
Yeah.
So what if we instead had ground users, so somebody who was a subscriber to both Amazon Kuiper as well as OneWeb, for example, acting as a gateway between those two networks? Or what if you go up and down from sky back to ground and then back up to sky, back down again, with multiple users acting as relays, just like you have relays within Tor? Would either of them kind of help your privacy?
Yeah, I think I mentioned it as very quickly. So if you had multiple accounts and different dishes to communicate over different constellations, basically as one of the relays, you could certainly, provide that protection against that single entity from being able to observe all the information, right? You're spreading it over more parties, so you might even call it decentralization, but I don't like to lean on that word. But that's definitely, you're right. You can definitely do that. The other thing you could do is you say, well, I want diversity amongst my relay operators. I want them to have accounts with different companies, not necessarily the same company, right? And I expect that might be more likely to occur in different parts of the world where there are different companies, that are able to operate. For example, I know this is like an extreme example, but there's countries where they want to deploy their own constellation, and they want their users to use their constellation, and other constellations are not allowed to operate above their airspace. For example, like China, Starlink cannot operate above China. They have to stop broadcasting when they go over, right? So I think diversity in that sense might be more, it's not a technical problem. It's in the sense that as long as you have enough companies out there, they may not necessarily have to communicate with each other, like allow for example, inter-satellite connectivity, but at least at the ground level where the customer can decide, which service to go with, then I think definitely that would be much more practicable in the near term.
Thanks. Yeah, that clarifies it. Thanks. Yeah.
So Tariq, I have a follow-up question on that. So the internet is great for Tor because it offers a lot of diversity, right? So if we are moving from this internet diversity to still like using a few satellite providers, won't that still be making Tor vulnerable to, for example, traffic correlation attacks?
Right. So that's a good point about, we want diversity. So this proposal, or at least the one before, we were looking at it as a hybrid. You don't necessarily use only satellite links, right? You still continue to use terrestrial links where it makes sense. And if you see the map of where Tor relays are, the majority of them are in Germany and in the US. And it's much faster to go between those distances just using a terrestrial link than go up into space or do any sort of intersatellite connectivity and come back down to Earth, right? So it's only when you pick, things that are like going across the Atlantic, for example, US to Germany, then you might pick that one path, one hop, to be like, let me use that hop, go over a satellite link, right? And the rest of the time I'm using terrestrial links anyway, right?
Okay.
So definitely you don't want to get into a situation where you're like, there's only 2 or 3 companies and that's it. Because I don't imagine there will be hundreds of satellite. I mean, I don't know, maybe as we
Probably not. Yeah.
right. I mean, at the end of the day, we think we have a lot of diversity on Earth, but everyone uses BT network here in the UK. Everybody else is just reseller, right? Maybe there's like some other people who actually own the physical lines, right? Some other networks, but there's not that much diversity really when you look at the physical reality of who actually has physical control of those connections, right? Because the data is still flowing over the underlying tier 1 or those guys networks in any case. Yeah. So there was a question on the chat. Mohammed said results in slides 23, 24. Let me okay.
Yeah, it's mainly about the accuracy of the figuring out the website. Would that be difficult if the routing is more challenging?
See, this is amazing. So the website fingerprinting, the beauty of it is that you treat the Tor network as a black box and you only look at traffic going in and out of it, right? So as long as whatever characteristic, the like traffic characteristics that this network, that's black box is adding, as long as it's somehow, noise and it can be canceled out, right? It doesn't really matter how you're doing anything. So even if you had intershell, what do you call it? Like constellations where you're bouncing, if you're not going to add any kind of delays, any kind of perturbations of that nature, the correlations are still going to stay, right? Things would just maybe get stretched out in time or bunched up in time. You're just not adding any other kind of, correlation breaking things. So in website fingerprinting versus the stuff I talked about earlier, where we don't consider things like adding delay and perturbation. So I know, Mohammed, you and I and Sean, we've been talking about how we might, add perturbations and noise and stuff like that to traffic to break this kind of correlation. That's not what website fingerprinting even considers. They kind of assume Tor is a first in, first out network, right? Transit the packet as quickly as possible. And we're trying to reduce that delay completely. So if you allow yourself the ability to delay things, then yes, then you could do maybe the kinds of things that you were talking about, where you go around different shells.
Okay.
So I kind of know we are
okay.
almost out of time, but let me still ask another question. So LEO networks are costlier compared to terrestrial ISPs and are bandwidth constrained too, right? So will that impact how Tor operates or performs today?
So definitely the economic aspects are not as attractive as, for example, the kind of thing you could spin up in the cloud, like some virtual hosting, some hosting company can put a Tor node on their server, like on Amazon, whatever. The kind of pricing you can get there is going to be super low, right? So you definitely cannot compete there. But one of the things we explored and I didn't present here was just how many relays need this satellite connection so that you could at least get the speedups that we're talking about. And we found that if you target the top 25% in terms of, so relays are picked based on the amount of bandwidth they provide, right, in Tor. So the top 25 bandwidth, by bandwidth relays, if they put satellite connectivity, we would see like you would get 80% about that of the benefits that we were talking about. And if you look at the top bandwidth relays, they're pretty beefy relays. So I'm wondering maybe it's not that huge of a difference in how much they're paying to get this kind of benefit. And a lot of these people who are running these relays are in it for they're not in it for the money motive. They're in it for the, trying to do something good.
Sure.
And trying to, I mean, they're all volunteers, right? They're already kind of doing that. But yeah, it wouldn't be the long tail that we're expecting them to put satellite links, because that would be way out of their league. And some of these people are like they have like a Raspberry Pi and they just connect their internet connection and they're like, here's a Tor relay for you, right? And it has like a bandwidth limit capped at like 2 megabits per second, right? So we wouldn't expect them to be doing it. But the good thing, what we found was that by targeting the top bandwidth relays, you could still get a large amount of that latency reduction. So you could
Awesome.
maybe,
all
yeah.
launch our own little satellites like CubeSats at like
Yeah.
$10,000 or whatever, and
True,
then
true.
connect among ourselves, like bootleg everything.
That would be really awesome because now one of the things I didn't mention in the inter-satellite link is you kind of assume that the satellite itself would do some Tor functions, right? It would allow you to run some of the routing that Tor is doing. So right now, until what's their name? Starlink starts allowing you to run code on the Tor relay, on the satellite itself. Like, I don't know at what point it'll become like edge computing where you're like, yeah, so you just send your function up to the satellite and it runs it for you. Until that day comes, I think it would be not likely that you're going to convince Starlink, hey man, can you start running this Tor VM on your satellite? So I think the idea of CubeSats might be a cool kind of alternative.
Of course. Thanks. With that, let's thank Professor Elahi once again. This was a great talk. So with that, I wish everyone happy Thanksgiving, and I hand it over to Nishant again for the closing remarks.
Yeah, no, I think we didn't when we set this up for Thursday 28th, we didn't realize, not being in the US, that this was also going to be Thanksgiving. So thanks to everyone for attending. This, if it was a holiday for you, then thanks for attending despite the holiday. Yeah, and we'll be back soon again, probably in the early next year. So thanks to both Professor Divakar and Professor Elahi for two fantastic talks.